Let's go through each problem on the pretest. Make sure you understand how to get the solutions. Question number 1, we just draw a simple little timeline here. And in year 1 you get $20,000. And the question is, what's the present value? So that's $20,000 divided by 1.07 to the first. The answer is B, 18,691. Question number 2, we have a need to draw a timeline here. So you're going to get $2,500 per year starting in year 1, and it goes to year 19. So N is equal to 19, payment is equal to 2,500. Present value is what we're looking for. We're looking for future value. Present value is equal to 0. The interest rate is equal to 10%. Now present value is equal to 0 because there's nothing here, right? This is nothing in the account today. So when we press the future value key, the future value is going to give you the value at year 19 because that's when the payments stop. That's what the question is asking for. The answer is D, 127,897. Okay, 3, we're looking to find the price of a bond. We know a bond has a payout rule. N's equal to something, payments equal to something, future value is equal to something. So what is that payout rule? Well, the par value is 1,000. So just let me draw the timeline again just as a reminder. The way a bond is going to work, it's going to make payments starting in one period, and this is semi-annual, and it's 13 years, so it's going to make payments starting 6 months from now and go for 13 years or 26 half years. So N's equal to 26. The coupon rate's 4%, so 4% of 1,000 is $40. But it pays twice a year, so that's $20 every 6 months for 13 years and $1,000 at the end. So this is the payout rule. Now that I know that payout rule, I'm also told that the yield to maturity is 4.2%, so 4.2 puts a semi-annual pay bond divided by 2. You plug this into your calculator, press the present value key, gives you 980.12. Okay, question number 4. We want to find the yield to maturity of the bond. This is going to be a lot like question number 3. We need to have N, we need to have a payment, we need to have a future value. That's the payout rule. Now we're given a present value and we find the yield rather than having a yield and finding the present value. So the payout rule is 14 years to maturity but pays semi-annually, so there are 28 payments. The par value is 1,000. It's a 8% coupon. 8% of 1,000 is 80 divided by 2 because it's semi-annual. That's $40. The present value, you have to make this negative, is 980. Remember, the calculator wants it negative because it's looking at it like this. If 40 and 1,000 are positive, that means you're receiving that money. So if you're receiving that money, you're buying the bond and paying the 980 today. You could flip the signs because somebody's selling the bond and making the payments. Right, so we come up with a IY here of 4.1217. We need to multiply that by 2, and we get E, 8.243%. Okay, then this one, if the yield goes down, well, think about when you do bond price. Let me pick a little different color here. Say the price of a bond, and we'll do this one, was 20 divided by 1 plus some interest rate, in this case 0.21 to the first, plus 20 over 1.021 squared, plus, and it goes all the way out to 1,020 divided by 1.021 to the 26th. Okay, well, I don't care if that's 9 going down to 8.9 or if it's 2.1 going down to 2. If I replace this with a lower number, so that would be like 1.01 squared, what happens to the denominator? The denominator is smaller, which means the ratio is bigger, which means the price goes up. So if the yield decreases, the bond price increases, and the reverse would be true. Okay, let me get questions 6 through 10 ready. Okay, question number 6. We're trying to find the price of a stock, and it has constant growth. That's good news. We know the constant growth formula is P0 equals D1 over K minus G. We're given D1. This is going to be an easy one then, $3.30 divided by the required rate of return is 0.17 minus the growth rate of 0.05, and that's going to be 2750A. Number 7 is very similar. It's the same setup. It is a constant growth stock but it says look, it's going to decrease at a constant rate. Well, that's okay. We still use P0 is equal to D1 over K minus G. In this case, we're not given D1, we're given D0, $1.30, but we know that D1 is equal to D0 times 1 plus G. So 1 plus, but the growth rate is negative, so it's 1 minus 4%, because it's decreasing at 4%. K is 12, so K minus G, but G is a negative, so plus 0.04. And that gives us A, $7.80. Alright, let's go up to number 8. 8, we're looking to find the growth rate. So once again, this is going to be a constant growth model. So P0 equals D1 over K minus G. As soon as you see constant growth, you know that's what you should do. P0 is $30. D1, I don't know, I just have D0, but D1 is equal to D0 times 1 plus G, and I don't know G, divided by K, 0.14 minus G. So doing the math here to solve for G, I have 30 times 0.14 minus G is equal to 3 times 1 plus G. So 4.2 minus 30G is equal to 3 plus 3G. So subtracting the 3, I can't write the number right. 1.2 is equal to 33G. G is equal to 1.2 over 33, which is 3.64 after a little rounding percent. Okay, so the pizza guys here. We're going to have non-constant growth for the first 3 years. It doesn't pay a dividend, and then it has constant growth after that because it's 4% forever. So P0, when you see 3 years of non-constant growth, regardless of what those numbers are, it's D1 over 1.18 or 1 plus K, D2 over 1 plus K squared, D3 over 1 plus K cubed. We go out 3 years because it's got 3 years of non-constant or weird growth, and then after that it grows at a constant rate. So then we need P3 over 1.18 cubed. So we have to figure out D1, D2, and D3. That's easy. That's 0. So these go away because each one of these is 0. So I'm left with the price a day is P3, the price in 3 years, divided by 1.18 to the third. Well, P3 is equal to D4 over K minus G. D4 is equal to $3. D4 is $3 over K, 0.18, minus, now it's growing at 4%, and that's equal to $21.43 Plugging that in here, 13.04. All right, last one, number 10. We have a stock that grows at 20% for the next 2 years and forever after that, so we know we need to have P0 is equal to D1 over 1 plus K. We're not given K. Let me come back to that. Or D2 over 1 plus K squared plus P2 over 1 plus K squared. Because we have 2 years of growth, we go out 2 dividends and then find P2. What about K? K is given by the cap M. K is equal to the risk-free rate, which is 2%, plus beta 1.1 times the market risk premium, 0.05. Now, if this is said expected return on the market, you would do this. But it didn't say expected return on the market risk premium, so you keep it like that. That's 0.075. So this is 0.75, 0.75, 0.75. Now we just need to find D1, D2, and B2. D1, do that in a different color. D1 is equal to D0, which is $2.10 times 1 plus the growth rate of 20, because it grows fast for 2 years. That's 252. D2 is equal to D1, which is 252 times 1.2, which is equal to 3.102. And P2 is equal to D3, which is 3.102 times 1 plus a new growth rate of 3% over K, 0.075 minus G, that's equal to 69.216. So put this in for P2, put this in for D2, this in for D1, crunch through the math, and you should come up with 64.81. Alright, those are all the problems, but let me give you just a little bit of a review from 3300. Here are the main things you need. You need to know how to price bonds. The price of any financial asset is the present value of the future cash flows. So bonds are going to look in general like this. They're going to pay, here's today, they're going to start paying next period and pay for some number of periods. So let's just say we know the bond has 10 years and it's semi-annual. So 10 years to maturity, semi-annual pay, it's going to pay for 20 periods. So we know it has a par value of 1,000, so $1,000 par. We need to know some kind of coupon rate. So that coupon rate is given to us, and let's just say it's 5%. So 5% of 1,000 is 50, but since it's semi-annual, you're going to pay 25, 25, 25, and then 1,000. That's the payout rule, where we know n is equal to some number, in this case 20. We know the payment is equal to some number based on the coupon rate, in this case 25, and we know the future value is equal to the par value, in this case 1,000. So like I said, this is a payout rule stated by whoever issued or sold the bond. And then if you tell me the yield to maturity, I can put that in and I can give you the price, which is the present value. This yield to maturity needs to be divided by 2 if it's semi-annual, and that gives me the price, which is a negative number. So you have here 1, 2, 3, 4, 5 different variables. If you're given any 4 of these 5, you should be able to find the 5th. But once again, the idea is the value of a bond is the present value of the future cash flows. Figure out the future cash flows, figure out the discount rate, and you can find the price. The other thing you need to know are stocks. Stocks work, or valued, I should say, they're valued the same way in the sense that you want to have the present value of all the future payments. Let me do that timeline style. The difference in a bond and a stock timeline, the stock goes on forever. It never ends. we're assuming they pay annually. You could change that assumption if you wanted to, but in 3300 we assumed it paid some dividend, D1, D2, D3, and it paid those dividends forever. And to get the price, you found the present value of all those dividends. The first model we assumed was what we call constant growth. That constant growth model means P0 is equal to D1 over 1 plus K plus D2 over 1 plus K squared plus D3 over 1 plus K cubed. Remember, we have to do this an infinite number of times, except we assume in the constant growth model that D1 is equal to D0 times 1 plus G, and that D2 is equal to D1 times 1 plus G. See the pattern? D3 is equal to D2 times 1 plus G. So every dividend, every year, the dividend grows at constant rate G. You can then go down to the math department and have some guys there do some algebra for you, and they'll show you that this is equal to D1 over K minus G. So even though it may not look like it, I want you to recognize that this formula is simply the present value of all the future dividends, assuming constant growth. The other thing we could assume is that you don't have constant growth. So we call this model number 2 non-constant growth. So in this case, it's still the same idea. I want the present value of all the future dividends. Well, we say for some number of years, let's just do 2 years, the dividend grows not at some constant rate G forever, but for, I don't know, it could be 5%, 10%. You could just somehow estimate or predict what these dividends are going to be, and then it becomes constant growth. So that would be P2 over 1 plus K squared. So P2 is equal to D3 over K minus G, because now at this point it's become a constant growth stock. Okay, the last thing you need from 3300. Well, you need more than this, but the last really important thing is the cap M. Where does this K come from? Well, K is equal to the risk-free rate plus beta times the expected return on the market minus the risk-free rate. And this whole term here in brackets is called the market risk premium. So there, in 20 minutes, under 20 minutes, is everything you need from 3300. Almost.